Welcome to the Arista Pre-Sales Enablement Series for Partners. My name is Laban Hickling, and I'm a systems engineer on the Arista Channels team. In this session, we will be covering CloudVision Studios. We do everything possible to ensure all of the information provided in this deck is accurate and up to date. Any information regarding third parties is obtained from public resources. I'll just give a few moments for you to review our disclaimer. The Pre-Sales Enablement Series slides and recordings along with this one are available on our partner portal. And we have 3 levels, 100, 200, 300, increasing in detail as we go. And CloudVision Studios is here in the middle at 200. Our topics for this session will go into an introduction of Studios, we'll look at the architecture of Studios, the built-in Studios, and then the elements of customizing Studios. The evolution of config management, to take a look at where we are today with CloudVision Studios. Legacy-wise, we had a flat config file that was applied per device, and it was driven by the command line. And then with CloudVision, we have the concept of configlets, which are configuration snippets, that we applied to containers via a hierarchical model. And it was a network-wide scope that had a config-centric GUI. Today with CloudVision Studios, we have a layer of abstraction. So we have a network data model, and we'll get into the elements of Studios that make that possible. But the scope is network-wide, and we have a workflow-centric GUI. So in the build process, we have an inherent workflow that you'll see that takes you from the requested and required input to ultimately driving desired network state through a workflow process. Some of the key features, the benefits of Studios: a quick point and click network automation, flexible, easy to use wizard-like GUIs. So the wizards themselves would be the Studios, and the workspace used to incorporate those Studios. And we have network-wide data models, again allowing us that flexibility and ease of applying configuration where we need it. And we'll look at that in more detail as we go. So side-by-side comparison of that, we have on the far left a standard configuration file, and then in the middle we have CloudVision's configlet-based configuration. And then Studio-based configuration, we'll see its configlets are created via these Studios. We use tags to identify which network elements we want that configuration to be applied to, device or interface. And then we have a workflow, so the user operator is guided through which inputs are needed, and then there is a change control process that's incorporated. The elements of CloudVision Studios is primarily centered on our workspace and Studios. So down at the bottom left, we have a workspace, and that's where user proposed changes would go. And that might be analogous to the Git commit and GitHub. And we have a build and validation component where inputs are validated, and there's a review of what that configuration might look like. And then we have the Studios themselves, which are ultimately the single source of truth. And that might be analogous to code repository. So we use Studios to update configuration, and then the ongoing source of truth is stored in those Studios. And what this looks like holistically, so we have the engagement of Studios through a GUI or API, and that will all start via a workspace. That's our staging ground. And within a workspace, we incorporate the Studios, and that's where we define which data inputs we need, and then that is used to create a configlet. The scope of the studio, we use tags to define. So which devices and which components of the network do we want this studio to be applied to? And then there's a build of that. So we're building configuration off of the studios and tags, and that's going to create a configlet. So all of that at the upper half of this diagram is the studio's feature set, and that gets integrated into the existing CloudVision elements. So ultimately, Studios is going to create a configlet, and that's going to be incorporated along with the static configurets that we've created in CloudVision and configurets via configurate builders. And that will all determine the design configuration. And then through change control, we'll apply those configurations to the devices. So the configuration generated via Studios is combined with configurets that may have already been defined at the container level to ultimately come to the full network desired state. So with Simple Studios workflow, we create a workspace, so our staging ground that's accessible via the GUI or API if you're running scripts to generate this. And we have a multi-operator environment where more than one operator could be working on a workspace with multiple studios to ultimately create the network desired state. So that workspace will create the proposed changes, so the desired state of the network. And then we'll validate those proposed changes. So the inputs that we make on a studios are validated for valid inputs. And then there's a configlet build for each device, and then you'll review the proposed changes. And then those proposed changes will be deployed with a change control window. And that could be scheduled immediately or later on the line after they've been validated by maybe a separate authoritative entity. And it's a multi-stage orchestration where you could have other actions incorporated before and after the configurations are applied. So workspace. So workspace again, have to create it prior to anything else. It's where we stage everything. It's where all changes are made. Gives users the ability to look at the changes before they're applied or before they're committed. Only once the workspace has been submitted will it be created and ready for execution. So you create a workspace, you tie the studio into the workspace, you associate the studios that you need associated to the workspace to make the changes that you need to make. And then when you submit that, there's a build created that makes the next version of studios, of that particular studio, which becomes the source of truth. And then that creates a change control, which will have the actual task of applying the configuration to a device. That workspace also allows multiple users to work on studios as one whole commit. And then again, once that workspace has been submitted, it creates the main line, as another way to put it. So we have a workspace, we create the workspace, we associate studios, say for example, building layer 3 leaf and spine. We associate that studio with the workspace. That studio had everything in the existing network state. So we're just making changes or adding configuration to where we need it. And then once we submit that, we are updating the main line. So the next time you pull that studio, it will have the changes that you made. So a studio is a guided point and click user interface, as we see illustrated here. So it's a network-wide configuration and applied to configuration elements that you associate to that studio via tag. So if you wanted a whole data center, every device within a data center to have that studio's config applied, you would associate the data center tag to that studio, and it will pull in every device that's been associated to that data center. And you can get further and further into the detail or specifics of what you want to associate with that studio via further tags. So multiple tags. You may have a tag for the data center, then you would have another tag for any device that was a spine and any device that had a leaf. So the multiple tags associated with that studios will further drill into where that config is actually applied. And these studios can cover tasks from day 0 to day 2. So it could be standing up a campus, could be standing up a data center EVPN, or as little as changing a port configuration, a port profile, changing the VLAN, or applying voice over IP specific configuration. The scope of the change, it can be a number of different things, from, again, the whole network, where you might have something like DNS configured, NTP, so group configuration, where you might just identify the site tag, what data center you're needing to the configuration to be applied to, or you could do it via network-wide configuration for specific tasks, like building out a leaf spine fabric or a campus fabric, and then they can be applied to single devices or port profiles. But all of this is done via tags. So you create the tags that you need to associate to specific studios, and then once that a studio has the specific tags applied, those tags incorporate the devices and interfaces that the ultimate configuration will be applied to. So tags is just a label value. And here on the bottom left, we have an illustration of what those tags might look like. So you have a greater tag for campus, and then further tags, again, hierarchical, right? So you could get down to a specific interface. So you'll have campus and then different pods in that campus. You might have the campus spline, and then each campus leaf will have a tag, and then the interface. So if I wanted to apply a configuration to the interface, I would have all of those incorporated tags associated. Here we see on the bottom right the campus pod tag with the value of pod 3. So that has pulled 3 devices into this studio because each of those devices was associated with the tag pod 3. So tags have been used previously in CloudVision for telemetry, and it's the same concept as containers in the way that we applied configlets previously. We're just taking that a little bit more detailed into being able to get right down to the interface. So tags are just a way of differentiating where configuration should go. And obviously those tags should make sense to what it is. So putting this together, and as we go along, hopefully these new definitions start to make more sense. But we have a studio definition. And within the studio, we can look at a studio as the role or task that is trying to be accomplished. And by that I mean, are we trying to build a layer 3 leaf spine, or are we trying to build a campus fabric, or are we just creating an interface profile? So the components of that studio will be tags, so we get the proper devices and the interfaces within those devices associated with the studio. And then we have an input schema, and this defines the user workflow. So the input schema is going to identify which variables or which input is required to complete the configuration of that specific studio. So I will have a input schema, and that is just elements of EOS to be configured. So when we open a wizard-like GUI for a studio, it will have fields where information will need to be added, input to be, and that will be network space, VLANs, VNIs, BGP, ASs, so on and so forth. So within that studio, you have information elements, the input that needs to be entered. And that's all defined within the schema. And the schema is just the elements of the EOS to be configured. And then we have a template. And a template is the background scripting that occurs to take the input values that were entered through the studio and create a configure. Those studios themselves establish what our mainline code is going to be. Our mainline code for our desired network state. And we stage all of this through the workspace. So we have created a workspace. We associate specific studios that accomplish the task that we're performing. Again, creating a layer 3 leaf and spine, or maybe just extending a VPN service. But we'll do that in a workspace. We'll associate the studios and make the changes to those studios. And then when we submit that, we're going to create a build. And that build is going to be saved to our mainline, our studios, our ongoing mainline studios, our code repository. So that the next time you pull that studio, it's going to have the updated configuration changes that were made. So in this CI/CD pipeline, this workflow, we have you're configuring the studios via the workspace. The studios is copied into the workspace. The updates are made in the build, and then it's saved to the next iteration of that studio. Once that's done, it's submitted to change control. And so now within change control, we have all of the things that we had with change control previously. So you have a level of approval that might take place. You could schedule them out. And then you can also introduce tasks before and after that change control. Or within the change control, but before and after the tasks within the change control. And then once that has been completed and executed, approved and executed, we have the configuration pushed to the devices. So to get into a little bit more detail and hopefully make this clear, we have inputs. Starting from the upper left, we have inputs, and these are the configuration variables. So any information that you think you would need to be inputted, network space, VLANs, VNIs, BGP, ASs, so on and so forth. Those elements that were entered are validated as being acceptable. Then the tags are going to pull in the devices interfaces. Again, just defines the scope of where those configurations are going to be applied to, the affected devices. And then the studio template is going to translate that input into a configuration. So we have the tag devices. So we see here on the left, we have a workspace. That's where we start. We associate studios, different studios with that workspace. Could be one or multiple studios, depending on what you're trying to accomplish. The tags are going to associate the devices that need to have the configuration applied. The input from using the wizard-like GUI for that studio is going to be used by the templates, and the templates are the back-end Python that is creating the configuration. So there's a resulting CLI from all of this. That resulting configuration is stored in the configuration repository. And then that is married with existing configlets. So the resulting configuration from Studios is combined with existing configlets to make the ultimate proposed configuration, the desired network state. And then that creates a task and change control, which is then pushed to the devices themselves. Looking at an example, so we have here in the middle a workspace that we've created. And we have 3 studios we want to associate with that workspace. So we have the L3LS Studio, the EVPN Service Studio, and the Interface Manager Studio. And so we associate those studios with the workspace, and we end up pulling in the existing network state. So those studios contain the configuration of the existing network state as it applies to each studio, the pertinent configuration. And then now we are able to make changes to that existing state, which will ultimately get updated into the configuration repository or the next iteration of Studios. So here we want to add EVPN services and remove EVPN services to specific devices within the data center. So we pull in the New York data center from the L3LS Studio, and then we pull in all the EVPN services that are available in the EVPN Service Studio, and we make a change. We add Service C and we remove Service B, and then we add tags to this workspace to associate this configuration with specific devices in a specific data center. So we wanted this applied to New York Leaf 31 and New York Leaf 32 inside of the New York data center. So the result of this will be the next iteration of these studios, which is just now mainline. So now our mainline has been updated with the changes that we wanted to make. And so our state now, after this workspace has been submitted, we see that we have Service A and Service C. So Service B has been removed and Service A has been added. The interfaces that are then going to be associated with this are associated via the Interface Manager Studio. And then we see the tags for the devices that are going to be associated. The relationship between the Studio's configlets that are going to be created via the workspace, and how those relate to existing configlets and containers. So the workspace in Studios is going to create a specific type of configlet, and it's going to be identified as Studios generated, and it'll be uneditable on the traditional provisioning, network provisioning tab, right? So when you go in to look at which configurants are applied to a specific device, you'll see a Studios generated config, but you won't be able to edit it. That you only can edit and create, edit, and do anything within Studios within a workspace. But you will see, along with the Studios configlet, you'll see the configlets that may have been applied in a traditional method, like applying configlets via hand jamming command line or config builder, and then those all will collectively make that device's desired network state. So within that, there is a priority to which the configurates are applied. So the reconcile process. So if you have a reconciled configurate, that is going to take precedence over a Studios generated config. So if you have something that applies to, well, if you have a service or a specific configuration that is shared between a Studios generated configurate and a reconcile configurate, the reconcile configurate will take precedence. So if that is changing the NTP/IP on both a Studios generated configurate and a reconcile configurate, the reconcile will take precedence. And then Studios generated configurates take precedence over static or configurate builder generated configurate. So there's just as a priority mechanism there for overlap. Rollback, the rollback process hasn't changed. Still only affects the running configuration of the device. And then containers. So traditionally we applied configurates to containers, and you could still do that. But now within Studios, the way that we apply configurates to devices and interfaces are via tags. So tags have now become our way of assigning where we want configurations to go, or defining that scope. So our built-in Studios, day one, we have Campus Fabric, and there are others, but this gives you a sense of what the built-in Studios will do, and kind of more getting in familiar with what a Studios is. So we have day one provisioning. So a day one provisioning studio would be Campus Fabric. So it's built on UCN campus design best practices. And then we have the layer 2 MLAG and L3 routed designs. There's also a layer 3 leaf spine fabric. So it configures a leaf spine EVPN using BGP as the underlay, MLAG leaf pairs, and EVPN configuration on a leaf and a spine switch. So within the layer 3 leaf spine fabric studio, you will have all of those input values that you'll either drop down to select or enter into a blank field what those values should be. So when we create these studios or we use a built-in Studios, again, that studio is going to pull existing network state and populate those fields for what's already been defined. And then within the schema, right, that creates that studio, within the schema that creates the studio, you're going to be defining what you want that field to be. So do you want it to be numerical? Do you want it to be text? Do you want it to be a query value, like a tag? So on and so forth. So within these studios, the elements that you're going to be populating are going to be based on the task that you're trying to accomplish. So MLAG peers, what are the configuration elements you think you need for creating an MLAG peer? But the options to populate that field are going to be limited to what's expected, or maybe a drop-down list, or it may already exist if it's already configured in the network state. So day two provisioning, as we drill down and get more specific within the devices, it might be a campus port manager, an interface manager, segmentation for our MSS group. You might just be extending a VXLAN service or general system configuration. So we have now studios that go from day 0 to day 2, and then you might assign different roles to operators at different levels, where certain operators are only provisioning day 2 port profiles, and a more higher level engineer would be creating fabrics. So we have categories of studios. Network fabric studios, they're designed to provide consistent provisioning for campuses and data centers. So now you have this layer of abstraction that was created via using studios and expected data values. And so now those are only needing to be populated to create the configlet. So there is less of a need to know every line of code that you need to configure, and may even be just a drop down of a few choices, again, further limiting errors. So a level of abstraction that allows speed and flexibility. And, they're all point and click for simple operation. And so that provides us an out of the box CI/CD. So you open this, create the workspace, open the studio. The studio is going to limit you to what you can configure with easy to understand areas of configuration or elements of configuration that are going to be required to complete the studio. IP addresses, VLANs, VXLAN IDs, VNIs, so on and so forth. And then creating a workflow in terms of the workspace, associating the studios with the workspace being able to be validated, and then observing the changes you're going to make via that workspace, and then that ultimately creating a task and change control. So along with the network fabric studios, we have functional provisioning studios. So these are the built-in categories of studios. You have studios defined by, I would say, task. Some of those examples might be user management, segmentation, configuration of DNS DHCP, point and click, same as the network fabric, and the same CI/CD workflow as the network fabric. So getting more into detail of what the L3 Leaf Spine Fabric Studio might looks like, again, based on best practice design via the Arista UCN. And so within the studio and that studio's request for data input, you'll have the best practices of that configuration behind the scenes. So the operator doesn't need to know all about the details of what the best practice for that BGP or EVPN or VXLAN configuration is. The studio is just looking for data entries. And then this would include everything from day 0 to day 2 operations. So our use cases for this might be day 0 operations, MLAG, BGP underlay, and the VXLAN EVPN overlay. Day 1 operations, add a new pod, add leafs to an existing pod, or add spines to an existing pod. So studios that would require a progression of lower and lower level details needed. Day 2 operation, stretch of VLAN, stretch of VRF. So less and less information needed as we traverse from left to right. Campus Fabric Studio, again, best practices applied in the design of the configuration. The studio itself is just looking for those data input values. The variables of the config of itself is being pulled from our best practices and populated with the input value. And like the L3 Leaf and Spine fabric, with day 0 to day 2 operations. Customizing and designing a studio. So studio schema is essentially the elements of EOS exposed and the values of those elements being defined by the specific type of input that is being needed for that configuration. So you have configuration elements of EOS, whether that be an interface or the BGP process. Within that configuration element, you're expecting a specific value. If it's an AS number, that would be numbers. If you're looking for an interface description, that would be a string. So we're taking the configuration elements of EOS, we're defining as what EOS configuration elements do we want to be a part of that studio, and then we're defining what input values are valid for that EOS configuration element. And so we apply constraints to what an operator can enter into that field of the studio itself. And they can be anything from strings, numbers, booleans to search strings, like you're looking for a specific tag. So we have simple input types, complex input types. So you look for groups of information, a collection of repeated numbers, or any type of input that can be repeated, or a resolver like tags. So it's looking for a specific tag that you would be able to search on. So all of these elements here that make up this schema, we're ultimately creating the data model that will be exposed to the operator via studios. And that consists of the configuration elements of EOS that we want to be a part of that studio. And then once the configuration elements of EOS have been identified to be a part of that studio, we're going to constrain what the input values can be by type, in either simple or complex. So out of the box, you have built-in studios, and those studios have a schema, right? That if you're doing an L3 leaf and spine studio, that studio has a schema, and that schema has all the elements of EOS that need to be configured to create a fabric, a layer 3 leaf and spine fabric, and then also which input types are valid for those configurations. And then so if you're trying to create your own and trying to customize a studios, you might just take an existing studio, clone it, and then make changes from there so that it's very easy to see where the baseline is. So you're just making changes. Obviously, it's going to be much easier from going from creating your own from scratch. As you get more used to it, it becomes much more easy to move around. So the studio template takes the input from the studio. So the operator creates a workspace, associates a studio to that workspace, and then starts entering values into the fields of the studio. And those values are taken in to the template, and the template uses Jinja 2 or Mako variants, and essentially takes Python in the background and creates a configlet from the input values. So you have a schema, which identifies which parts of configuration to incorporate into a studio and defines the values that are valid for the configuration or for the input values of the studio. Once those values have been inputted by an operator to create a config, the template is used to take those values via the Python in the background and create the end result being a configuration. So in that build process, input is entered into the studio's fields, and then through the template, which is Jinja 2 or Mako, takes the values and builds a configuration, a configlet. So I've walked into this a little bit, but editing studios, so any studio can be edited, just the method of how you get there might be different. So if it's a built-in studios, you can't edit the built-in studio itself, you clone it first, and then you can edit it. And then any one that you create on your own, you can edit those. You edit them via a user interface. So within the workspace, going to the studios that you associate, you then can hit on the upper right tab of the studios. You can edit it in the GUI. So you're either adding or deleting elements of EOS to be configured and then defining the variable type that you need to be part of that configuration of that EOS element. Or you could just configure this through a raw YAML file. You can import and export them. So there's multiple ways that you can edit it, but the easiest way to start and getting accustomed to editing it is taking a built-in Studios, cloning it, and then editing it up or down to the desired state or the desired task that you're trying to accomplish. So profiles allow for a set of configurations like a phone or a QoS configuration that might be similar to across the board to your network, maybe changing a little bit from where it's facing, and then you would change the name of those profiles, obviously, to associate to where in the network that configuration would apply. So profiles allow us to group configuration based on the role of that particular interface. So that covers the kind of theory, the back end of Studios. So to get into the specific configuration of Studios, there's a lot of good resources. A couple of them here. It's essentially the user guide for Studios, and we have couple links here for user guides, and that has pictures as well as step-by-step instructions in configuring Studios. And we also have studio demos for days 0 to 2 provisioning. And so there's a 5 to 7 minute demonstration of how you would use the studios that are built into CloudVision. So our key takeaways: Studios allows us point and click automation, and then we have flexible configuration via these wizards that then we can use built-in and customizable studios to drive configuration using our workspace that allows us for that CI/CD complete workflow management. So pulling in studios, the appropriate studios, into a workspace that will allow us to configure the parts of the network that we need to configure. We use tags to identify those devices and interfaces that we would like to be a part of the configuration of that studio. And then that studio's input values are collected by a Python script that creates and builds the configlet that we ultimately are allowed to visibly see and verify that it looks as we expect. And then we create the build that will create a change control, tasks within change control, that then we have the other elements of change control available to us, actions and ordering logic that we can apply, as well as approvals. So some additional related links for Studios, CloudVision install guide, which will have the configuration, and then video overviews, and then the links to the CloudVision configuration guide and the demos. With that will conclude this session. Thank you for joining.